Hello everyone, welcome back to my channel. As I've told you in this video, I'll be explaining you about the basic terminology related to hydropower engineering. In my earlier video, I've explained you about what is hydropower, what is hydropower generation, what is the phenomenon of power generation using water, and what is the classification of hydropower plants, on what criteria is hydropower plant classification done, and in that we have seen exclusively in detail about the entire classification. Right now in this video I will be explaining you about the basic terminology related to this hydropower engineering. These are the very common terms used in hydropower engineering. Okay, so the first definition what we have to learn is peak load. So what is peak load? I think you are all aware of the word peak, right? Peak means what? The highest, right? So peak load is also called as peak demand. Okay, peak demand or on peak. So what is this? See, I'll just try to tell you with an example. Now in every of our house, we use daily power, right? We use daily electricity, correct? So let's take a duration of 1 day. Let's consider a duration of 1 day. In 1 day, now when will be the power demand maximum, or when will be the power usage maximum? Generally in the evening times, correct? Why? Because in the evening we all return back from the college, parents return back from the offices, and we generally use the TV or whatever. So like this we expect generally in the evening times the power usage or the power demand to be maximum, correct? So this maximum demand is called as peak load. The highest value or the highest electrical power demand is called as peak load. This is for a particular time period. That time period can be a day, or it can be a month, or it can be an year. In any specified time period, the maximum or the highest power demand is called as peak load or peak demand. Okay, this why we are taking the maximum means because we require the maximum demand on that particular day, or in that particular month, or in that particular year. Okay, so clear? So again I'm repeating, peak load or peak demand is nothing but the highest power demand which will be recorded, or which is demanded by the people in a given time period. Okay, now as I've told you, in a daytime, generally in the evenings, if you consider a specific duration of 1 day, generally in the evenings it will be maximum. If you consider in a year, say suppose in a year, what will happen, especially in summer, in that duration of 2.5 to 3 months, we use mostly coolers and ACs, and we all stay at home, so we use a lot of power, correct? So there the max demand would be maximum. I'm just telling in a generalized way example. If you take a week, generally weekends or Sundays where we stay at home, like that. So these particular uh, time periods where we are getting the maximum demand, or where we are using the maximum power, that is called as a peak load. Okay, next coming to load factor. Load factor is nothing but it is the ratio of average load to the peak load. So peak load I have told you just now, it's the maximum load we are using. Okay, now I'll take the same example of 1 day as I've told you just now. So right, let's consider 24 hours. Okay, 1 day means 24 hours, right? Listen carefully. In this 24 hours, as I've told you, generally in the evening time we expect more usage of power. Okay, let's say at 5 o'clock. Okay, I'm just telling an example. Let's say at 5 o'clock I'm using the maximum power. Everybody is using a laptop or with a charge, somebody is using a desktop, somebody is charging the phone, or somebody is using an AC, or somebody is using a cooler, or somebody is watching TV. So like that, at a time, and siblings are sitting in one room, relatives are sitting in the other room. So obviously let's assume that at 5 o'clock the demand is maximum. Okay, let's say that at 5 o'clock the maximum demand I got was, or the maximum power I used was some 100 kilowatts. Okay, just assume I used 100 kilowatts. So at 5 o'clock in the evening, maximum demand was recorded as 100 kilowatts. Okay, Now, what is average load? You know how to calculate average, right? Sum of all the entities by number of entities. What is this average load? See, power is right from the morning. I told let's take 12-hour duration, right? Like from 12 a.m. to next day 12 a.m. Correct? So 12 a.m., 1 a.m., 2 a.m., 3 a.m., 4 a.m., 5 a.m. we got up, 6 a.m., 7 a.m. you started waking up, then 8 a.m. you started going to the using the washrooms. Next you open the you on the geyser. Next you on the TV. Your father puts on the fan. Then like this slowly the load is getting recorded. Then at 9 o'clock you leave the house, you just iron the clothes, you leave the house, and 10 o'clock you leave the house. Once you all leave the house, or else before you're leaving the house, your mother has to cook food for you, so she uses some kitchen utilities like oven or something else. So the demand, slowly the power usage is coming into action, right? And next, after some time, so after some time again, your mother has to put on the washing machine, and the fridge is also running. Like this, what is happening? The total, and again you come back in the evening, and again you put on the TV, something like this. Every day in 24 hours, we are using power supply. So just add all the power recorded for every hour, and just add the quantities by divided by how many hours we are taking, 24. So add the power duration consumed for every hour by 24. So you'll get the average load. So that average load divided by the peak load. The peak load, what we got, 100 kilowatts at 5 o'clock, right? So this average load by the peak load will give you the load factor. Okay, in a specified time period. Again, as I've took the example of one day, it could be for 1 year, for 1 week, for 1 month. It depends. That's called as load factor. Okay, load factor is defined as the ratio of average load to the peak load, and generally load factor is expressed in terms of percentages. Okay, next comes, okay, I'll tell you an example for load factor. See here, I've just taken a electrical bill, and electricity bill is generated for every 1 month, right? So I'm taking the billing cycle for 30 days. Okay, so see here, the peak demand was 436 kilowatts. Like in those 30 days, somewhere it was recorded 436 kilowatts. Okay, the demand, the highest usage was 436 kilowatts. And in those 30 days, we have taken the usage of power average that came out to be 57,200 kilowatt hour. Okay. Now, he is asking us to calculate load factor. So, load factor, what did I tell you? It is average load by maximum load or the peak load. So, load factor is equal to average is 57,200 divided by peak demand. Peak demand is 436, but we are doing for a billing cycle of 30 days. And see here, the average demand or the average load is in terms of kilowatt hour. So we have to convert this peak demand also into kilowatt hour. So how do you convert into hours? It is 30 days. So for every day you'll be having 24 hours. So 30 into 24 into 436. This will give us load factor, but I told you load factor will be expressed in terms of percentage. So 0.1822 into 100, I got 18.22 percentage. This is the load factor for this example. Okay, how many here? If it is here 1 year, what you have to do? You have to put here 1 year means 365 days. 365 into 24. Why? Because here it is in terms of kilowatt hour. If there is no hour here, if it's directly 57,200, you could have directly divided. So you have to see the numerator and denominator units. Next comes installed capacity. So what is an installed capacity? This is also called as plant installed capacity. Here plant means our hydropower plant. It is nothing but it is the total capacity of your power station. Okay, right. Now your hydropower plant will have small units, right? Okay, if you are so the summation of all the units is the capacity of that hydropower plant. Say suppose if your hydropower plant is having 4 units inside, 4 units are working, 4 turbines are working, and 4 units are producing electricity. Say the capacity of one unit is 20 kilowatts, the capacity of other next one is other power plant, other unit is also 20 kilowatts, third one is also 20 kilowatts, fourth one is also 20 kilowatts. So what is the total capacity of your hydropower plant now? 20 into 4, 80 kilowatts is the capacity. So it is the total capacity means what here? Yes, the amount of power generated by your power plant is called its capacity. Okay, so for a hydroelectric power plant, it is the total capacity of all the generating units installed in the power station. Generally, observe near the dam you have a power generation unit, right? You just observe there, it will be written the capacity, what is the installed capacity of that. In some megawatts or kilowatts, it will be written. This is a capacity, means this power plant can generate this much of electricity. However, all the units may not run together. Yes, it depends upon the input we are giving. Like it depends upon the availability of water. If the water is more, like if there is a flood season, you have a lot of water coming into your reservoir, then you can run all the units at a time. But during summer season, we don't have much water. So only which units will run, that unit only will produce electricity. But it doesn't mean that your installed capacity will change. Installed capacity means when all the units are running, what is the total capacity? Okay. Next comes capacity factor. What is capacity factor? It is the average output of the hydroelectric power plant divided by the installed capacity. Same as we have done in load factor. What was our load factor? Average load by maximum load. Similarly, our capacity factor will be the average output of the power plant by the total installed capacity in a specified period of time again. Okay, in one, say suppose I'm taking the example of the same 4 units which I've told you just now. So what is the capacity of my hydropower plant? It was 80 kilowatts. Why? Because in that hydropower plant I had 4 units. Each unit had a capacity of 20 kilowatts. So 20 into 4 is 80 kilowatts is the total capacity of my hydropower plant. Now, as I've told you, all the units may not run at the same time. Okay, let's assume still all our units are running, but we have to take the average, right? Depends upon the, as I've told you, it depends upon the availability of water. Say once all the 4 units are running, as days increase, slowly the efficiency of the units may come down. Okay, that is one possibility. Next possibility is, as I've told you, depending upon the water level. So now if the water level is less amount of power will be generated, right? So all this average of power generated from all the 4 units divided by its installed capacity. Like if I'm installing this plant, means how much electricity I should get, this much. So actually how much I am getting, this much. So this average by the installed capacity will give us the capacity factor. You can choose any specified period. Again, it could be for a day. I mean, in a day you can calculate what is the capacity factor of this hydropower plant. Means the installed capacity, means the benchmark for this power plant is this much, 80 kilowatts. But after running for 24 hours, it generated only this much power. So capacity factor is this much. Like this we will calculate. And generally capacity factor varies from 0.25 to 0.75. It's also known as plant capacity factor. So again, we'll consider a small example. I have a small hydroelectric power plant. Okay, so this power plant is generating 200 megawatts for the entire day. Like means it is generating 200 megawatts of power for one complete day. Here my specified time period is 1 day. Okay, then average output of the plant is 2400 megawatts. Okay, plant installed capacity. Now what is plant installed capacity? It is generating 200 megawatts for complete day. Means 200 into 24 hours. It is generating 4800 megawatt hour. What was the average? It seems on that, in that complete 24 days, what was the average? 2400. Now what will be capacity factor? Average output by installed capacity. So average output is 2400 by installed capacity is 4800. So that's equal to 0.5. Okay, this is the calculation for capacity factor. Here hydroelectric power plant generates 200 megawatts for entire day. Means if it runs for 24 hours, it should give us 200 megawatts. That's its capacity decided. But it was, means it should give 4800 megawatts of power for us. But it is giving only 2400. Means if I take the average, so capacity factor will be average by total, which is 0.5. Next comes utilization factor. What is utilization factor? It's the ratio of maximum output or load produced by the hydroelectric power plant to the plant installed capacity. Right, now I told we are taking the average, right? Okay, for your easy understanding, now let me take a duration of half day only. Okay, for your understanding purpose, I'm telling you. Say I'm taking the duration specified time period as 12 hours only. Okay, Now for this 12 hours, what is the installed capacity of my plant? 80 kilowatts, right? 4 units are running. Okay, 80 kilowatts is for one day, no? So half day means it should give us 40 kilowatts, correct? If it is running for 12 hours, if it is running for 12 hours, it should give us 40 kilowatts, correct? That's it is that 40 kilowatts is its installed capacity. Ratio of maximum output to installed capacity is utilization factor, means maximum output in this 12 hours at some time, I mean at the 5 o'clock or at 6 o'clock or at 3 o'clock, whatever time, at some time we will get the maximum production, right? That value, that maximum load in this average 12 hours, the maximum load we produced. See, in this 12 hours duration, let's say that for every hour I'm collecting the power, means at first hour I'm getting some kilowatts, second hour I'm getting some kilowatts, third hour I'm getting some kilowatts. Like this for 12 hours, how many values I will get? 12 values. If I add all these 12 values and divide by 12, I will get the average. In this 12 hours only, some value will be maximum, no, when compared to the other 11 values, right? That maximum load by the installed capacity will give us the utilization factor. Again, in a specified time period, that specified time period could be a day, a week, or a month, or a year. For a hydroelectric power plant, generally our utilization factor will be in between 0.4 and 0.9. It's also called as plant utilization factor. Next example, I'll tell you again. Same hydroelectric power plant, it is generating 200 megawatts for the entire day. If it runs for complete 24 hours without a break, it should give us 200 megawatts. That is its capacity, means it is 200 into 24, which is 4800 megawatt hour is its capacity. Average output means in that 24 hours, at some time 3600 megawatt hour was recorded. So what will be utilization factor? This 3600 divided by 4800, which came out to be 0.75. Like this, you have to calculate the utilization factor. Next, coming to estimation of hydropower potential. How do you generally calculate the formula for power, or how do you generally calculate the value of hydropower? See, to calculate this amount of power developed or produced from water, we need mainly two factors. One is discharge and one is the head. Okay, head is what is the head of level of water which is coming onto the turbine, and discharge means how much is the quantity of water flowing onto the turbine. Okay, there is a difference between them. Head is different and discharge is different. So this power generation, this power extraction will be dependent upon only these quantities, discharge and head, and hence it is given by the formula rho g qh. You know this formula already, right? If you want in kilowatts, you can just divide by 1000. So whereas rho is weight density, rho is density of water, g is acceleration due to gravity. So this rho into g is also called as weight density of water. Okay, so p can be also written as w into q into h. So where q is discharge flowing through the turbine, and h is the head available at the inlet of the turbine. So this is formula for calculation of power. This formula only we use to calculate the power generated, or nothing but your shaft power indirectly. Okay, so as rho and g are constant, your p will be depending upon q and h. So this is about estimation of hydropower potential. So by using this formula, you can estimate how much power you will get once you know the values of q and h. Say if your q is some 3 meter cube per second, if your h is some 10 meters of head, then just multiply 1000 into 9.81 into 3 into 10. You'll get power in watts. Divide by 1000, you'll get in kilowatts. Okay, then you'll have an idea how much power is generated. Okay, so this is about terminology related to hydropower engineering. One is peak load. It is nothing but the maximum load recorded in a specified time period. Next is load factor, average load. Whatever time period you are taking, just take the average of all the readings. That average by the maximum recorded will give you the load factor. Next is installed capacity. A hydropower plant may consist of small units, or it may be consisting of only one unit, whatever it may be. But what is the total capacity of power generation coming out from that plant if it runs continuously without any break? That's called as installed capacity. Capacity factor means the average of all the power extraction or power production in a specified time period by the installed capacity will give us capacity factor. Next is utilization factor. In those all readings in a specified time period, one reading will be obviously maximum when compared to others. That maximum reading or the maximum output by the installed capacity will give you the utilization factor. And next is hydropower potential. Once you know the values of discharge and the head available, you can calculate the power generated. That is given by the formula rho into G into Q into H, where rho is density of water, G is acceleration due to gravity, Q is the discharge, and H is the head available. This gives us power. We can estimate the power of water in watts. If you want in kilowatts, please divide it by 1000. Okay. Please go through the video once again. If you have any doubt, you can just contact me. Okay. Thank you.